Okay, so I just want to say something briefly about how we can actually think about how this. Okay, so I just want to say something. Okay, so I want to say something briefly about how we can actually use this evaluation arrow in practical situations, how we can understand. Okay, so I want to say something briefly about how we can understand this evaluation arrow in practical situations. Now, there is a attached video in the description where I go through an example of how to actually construct one of these power objects, and all of this will become more clear if you watch that video. But anyway, here's the basic idea. When we do this evaluation arrow, we want to basically do it on a theta from omega to the power of e. When we do this evaluation arrow, we want to basically do it on a theta, which is like a e-type figure of omega to the power of a, and an alpha, which is like an e-type figure of a. And then if we want to do this in terms of arrows, then the fact that this diagram commutes gives us that e after theta under arrow comma alpha under arrow is equal to theta under arrow anti-transpose after identity of hom e comma blank comma alpha under arrow. Okay, so we have that. But how does that help us? Well, the thing is that if we're really well, well, the thing is, we really want to ask, what do we know? You see, if we have omega to the power of a, we have this sort of set of e figures of it. But if we're really approaching the kind of power object from nothing, we really maybe don't really know what to call the elements of omega to the power of a of e, because they're not really the kind of thing that we have sort of direct experience of. We don't really directly encounter this set omega to the power of a of e. What we do encounter, what we can compute, are these sub-objects of hom e comma blank times a. So I always think that our sort of experience of what these kind of things are is really at this kind of level. And the way that we'd be writing a kind of element of omega to the power of a of e would be to say that it's would be to say that such an element could be written as the element corresponding to the transpose of the classifying arrow of M, where here M is some sub-object of hom e comma blank times a. Now this sounds complicated, but it's not actually that bad. Basically, just think about this kind of sequence of isomorphisms, okay? It's essentially changing theta into theta under arrow anti-transpose star. Now, what's the opposite way round? How would we convert this M here back into a theta? Well, firstly, we'd do a chi on it to get rid of the star. And then we'd do a transpose on it to get rid of the anti-transpose. And then we'd do a dot of it, we'd find the element corresponding to it to get rid of the arrow. So that would convert, that would find us this theta here. If we sort of do all these operations to our M, we recover our theta. So that's going the other way around. So basically what I'm saying is that since it's these kind of things like M that we can really get our hands on when we're trying to compute omega to the power of a, what we can say is that, well, we could write a sort of theta, which is an e-type element of omega to the power of a. We can write it as chi of M transpose dot for some sub-object M of hom e comma blank times a. So, okay, what are the advantages of doing that? Well, the thing is that because this diagram commutes, we have this kind of equation here. And the thing is then, if we just substitute this kind of formula here for theta, we find that this bottom line here is much easier to deal with, okay? Because if we insist that theta is equal to chi of m transpose dot, then what we have is that theta under arrow anti-transpose is just going to be chi of m. So in this case, this just equals chi of m of hom e comma blank comma alpha under arrow. Okay, so there's more examples of this that you can find in the kind of video where I go through power objects, and I encourage you to do that because it's very interesting and power objects are really important in topos theory. But just to sort of give you some vague kind of rough intuition, we can think of a sort of theta in omega to the power of AV as something like a sort of sub-object of hom e comma blank times A. And then the idea is that when we do this evaluation arrow, that kind of thing is going to be paired with a sort of E-type element of A. And then when we do the evaluation, what we're essentially doing is getting this sub-object corresponding to this kind of thing, finding its classifying arrow, and then seeing how that classifying arrow operates on our E-type element, okay? So we're essentially testing whether this is in this sub-object or not. And that, of course, gives us some value in omega, some kind of truth value. So that's the basic idea in a nutshell, but I encourage you to watch through that video where we go through a practical example so that you can really like get your hands on something concrete and understand this stuff properly. So it's very, very interesting. It's very amazing, like the kind of levels of abstraction and complexity we can get to by thinking about things like power objects and exponential objects, and the fact that we can do it in so many of these different categories of functors from C to Z.